episode 80 of the Snowflake Snow Pro Core Certification In-Depth Training Podcast, brought to you by Brightflux. I am your host, Yaqub Abdul Hakim, and as a certified Snowflake user, I'm thrilled to guide you through an important topic today: the effective use of the flatten command in Snowflake. The flatten command is a powerful tool in Snowflake's arsenal, allowing users to unpack nested data within semi-structured data types such as JSON, Avro, Awk, Parquet, or XML. This function is crucial for Snowflake users who work with modern data analytics, as it simplifies the handling of complex data structures and makes querying nested data more efficient. First, let's understand what semi-structured data is. Unlike structured data, which is organized into tables and columns, semi-structured data doesn't follow a strict relational structure. It's flexible and versatile, but can be challenging to work with using traditional SQL queries. That's where flatten comes in. To use flatten effectively, you need to know its syntax and operation. The basic syntax is scalar select, flatten, input as outer asks true core false, recursive setter true word false, mode says array object from. The input parameter specifies the column containing the semi-structured data. The optional parameters outer, recursive, and mode provide further control over how the data is flattened. Outer specifies whether the flatten operation should include null values. If set to true, null values within the array or object being flattened will be included in the output. Recursive determines if the flatten operation should be applied recursively. This is particularly useful when dealing with deeply nested data. Mode allows you to specify whether to flatten an array or an object based on the nature of your data. One key strategy for using flatten effectively is to pair it with a select statement to extract specific elements from your nested data. This selective querying can dramatically increase the efficiency of your data analysis. Let's go through a practical example. Suppose you have a JSON column in your table named Events that contains nested data about user interactions. To extract specific events and their attributes, you could write SQL select e.value type string as event type, eValue timestamp as event time from my table, lateral flatten, input extracts my table, events as e. This query uses flatten to expand each item in the events array, then extract and cast the event type and timestamp from the nested data. To master the flatten command, practice is key. Begin with simple queries and gradually deal with more complex data structures. Remember, the ultimate goal is not just to flatten data, but to transform it in a way that makes it valuable and insightful for your analysis or application. In addition to technical know-how, understanding how and when to use the flatten command can significantly contribute to your success in the Snowflake Snow Pro Core Certification exam. Knowing its applications, limitations, and best practices can help you navigate the certification's challenges more adeptly. As we wrap up today's episode, I'd like to remind you that proficiency with the flatten command, like any other aspect of Snowflake, comes with continuous learning and practice. Dive into real-world data sets, experiment with different scenarios, and share your findings with the community. Thank you for tuning in to the Snowflake Snow Pro Core Certification In-Depth Training Podcast. I'm Yaqub Abdul Hakim, wishing you great success in your Snowflake journey. Stay curious and keep learning.